Hello student, welcome back to my channel. Like last couple of video, today also I am going to explain very important topic from electrochemistry, which is nothing but a hydrogen electrode. And basically we are going to explain the galvanic cell operation by using the hydrogen electrode. Already we know what is galvanic cell. Galvanic cell is that device which will convert chemical energy to electrical energy. Due to chemical reactions, the chemical energy will be converted to electrical energy. That is the device only acting as a conversion of energy. Now, like in galvanic cell that operations, if both the electrode, that means as a anode we are utilizing hydrogen electrode, as a cathode also we are utilizing hydrogen electrode. It's like a concentration cell. That means the same substance is acting as a anode and same substance is acting as a cathode. If their concentrations are different, there will be a gradient of concentration. To equalize the concentration, there will be flow of electron from anode to cathode and there will be current generated from cathode to anode. This is the basic funda. Let us look at these cell representations where the hydrogen platinum will act as a this is a inactive electrode. With that help, the hydrogen, the electron will coming and going out. Platinum, hydrogen gas, then 2H plus, they will represent like this, and then double dagger. That means it's a galvanic cell. In that galvanic cell, this is a nothing but a salt bridge which will connect the anode and cathode. Not only connect the two half cell, but also it will complete the internal circuit so that the current can flow from cathode to anode. And then here in cathode, what will happen? 2H plus will be converted to H2 gas, and obviously here there will be platinum, and this is a solid platinum, this is a solid platinum. Now here the hydrogen gas pressure is 1 atmosphere or 1 bar, we can keep 1 atmosphere or 1 bar. And now here this H plus concentration, both the side, if you look at this concentration, suppose I can take it over here, that the concentrations, this is a anode, this is a anode, anode means always oxidation half, and this is a cathode, cathode means always reduction half. Now we construct one galvanic cell where that there is the same substance is acting as an anode and same substance is acting as a cathode. This type of galvanic cell we used to call it as a concentration cell. Now here the concentration of H plus and concentration of H plus in cathodic compartment and anodic compartment, that is not the same. Suppose here I am telling here concentration is C1, here concentration is C2, and now I am telling C1 not equals to C2, then only this cell will operative. Otherwise it will be a equilibrium. At equilibrium only the concentrations will be what? Same. But whenever there is a concentration gradient will be there, then there will be a what? There will be electron flow will be there. They want to equalize their concentration. When their concentrations will be equal, the cell will be inoperative. There will be no concentration gradient. Always there will be there. They want to equalize their concentration. So that's why the reactions will be taking place. That's why electron flow will be there from anode to cathode, and then there will be a current flow will be there cathode to anode. Now, if you look at anode wise, what is the reaction? In anode, what is that? Always you need to read out like this, left to right. That means H2 is converting to 2H plus. Here 2H plus is converting to H2. Now in anode, what is happening? In anode, H2 is converting to 2H plus by loss of 2 electrons. The loss of electron is a oxidations and the gain of electron is a reduction. Whereas in cathode, what is happening? This 2H plus is taking 2 electron and converting to H2. Now if you look at, this is my anode reaction, this is my cathode reaction. Anode means what? Oxidation. Vowel for vowel. Anode, A is a vowel, oxidation, O is a vowel. Like that you will remember, vowel for vowel. So then cathode, there will be what? Reductions. Now if you look at, there will be a reduction. Now whenever hydrogen is there, there will be pressure term is there. That's why here pressure is a 1 atmosphere. Now overall reaction, if I write down for this, This two electron will be cancelled out. This is a hydrogen, where this hydrogen is nothing but your anode, this hydrogen gas. Now anode plus here the 2H plus. Then if you look at that this 2H plus, where this is a cathode, this cathode H plus concentration now will be equals to 2H plus, where the 2H plus, this is a anode H plus. And now with that H2, where that 2H2, it is in nothing but a cathode. This is the situation. Now for this, if I write down the Q, now Q means the reaction quotient. Now in electrochemistry, whatever the reaction quotient we are utilize, maximum cases if you look at like a chlorine gas we using H2 to H plus, Cl2 to Cl minus, generally that Q will be QPC, that means in terms of a pressure and concentration. So that's generally in chemical equilibrium, ionic equilibrium we observe maximum cases either QC or QP, but here together combination QPC, that means both thing will be involved in the equilibrium, that means as well as concentration term will be involved as well as the pressure term will be involved. That's why this is generally will be QPC. So that's why here pressure term will be there as well as concentration term will be there involved in this process. Now if you look at this QPC will be equals to, we know, active mass or molar concentrations of the product or partial pressure of the product raised to the power of the stoichiometric coefficient by active mass or molar concentration of reactant raised to the power of the stoichiometric coefficient or partial pressure of the reactant raised to the power of the stoichiometric coefficient. If the product or reactant is a gaseous, we have to take the partial pressure. If they are ion, then we have to take their concentration, molar concentration. So that's why QPC expressions will be equals to H plus concentration to the power 2, where this is a anode, that's why I am giving A, then into partial pressure of H2, where this is at cathode, that's why I am giving C, by H plus concentration to the power 2, where at cathode, by partial pressure of H2, where at anode. This is my QPC expression. Now let us look at these things we will put down into the Nernst equation. Then what we will get over here, we will check it out. Now we know very well the Nernst equation, everybody knows it is coming from this derivation. Delta G will be equals to delta G naught plus RT ln Q. Here Q equals to QPC, RT ln QPC. Now this equation is deriving from thermodynamics. One equation is there, that delta G dG equals to VdP minus SdT. From there at constant temperature, if I do differentiate, we can able to reach, if you do integration, we can able to reach this equation. Delta G will be equals to delta G naught plus RT ln QPC. Now delta G equals to minus NFE in electrochemistry. Why? Because delta, by decrease of Gibbs free energy, only available form of energy, that means electrical energy, will be available by decrease of Gibbs free energy. That's why NF E cell will be equals to minus NF E naught cell plus RT ln RT ln QPC. We will write down like this, RT ln QPC, we will write down like this, RT ln, if you look at RT ln QPC, we will write down like this, RT ln QPC. Now if I divided by NF, what we are getting? E cell will be equals to E naught cell by minus RT by NF ln QPC. Now if you convert natural log to log, you have to take 2.303. Then our expressions will come. E cell will be equals to E naught cell minus 2.303 RT by NF ln QP log. This will be converted to log because we take it 2.303. So 2.303 log QPC. Now if you look at over here, this R value, if you put into the joules, temperature, if you take it room temperature, which is 25 degrees centigrade, and if you put Faraday equals to 96,500 coulomb, ultimately this equations comes to E cell will be equals to E naught cell E naught cell minus 0.0591 by n log of QPC. Now what is n? N is a number of moles of electron involved either in a oxidation process or reduction process in balance redox reaction. That is nothing but n. N is a number of moles of electron involved either in a oxidation process or in a reduction process in a balance redox reactions. Now due to that redox reactions, there will be electron flow will be there. Because of electron flow, that current will be generated. As simple as that. Now we got the expression E cell will be equals to E naught cell minus 0.059 by n equal and log QPC. Now already we know the expression. What was our QPC expression? If you look at this previous slide, there we derived that one. We will put that things over here. We look at the QPC equals to H plus concentration anode into partial pressure of hydrogen at cathode by partial pressure of hydrogen at anode into H plus concentration cathode to the power 2. Now if you put that 2 expression into that QPC, so then what expressions we will get over here, that we are going to discuss, and then from there we will get the hydrogen electrode, what will be the derivations. Now immediately if you look at E cell will be equals to, I can write down E naught cell equals to E naught oxidation plus E naught reduction. E naught cell equals to, I am writing E naught oxidation plus E naught reduction minus 0.059, I am writing 0.06 by n log of QPC. I am writing like this one. Now you look at for hydrogen electrode, E naught oxidation means at cathode what reaction is happening? E naught of H2 is converting to 2H plus by loss of electron. That's why H2 is converting to 2H plus, and reduction means 2H plus where it is happening in cathode. 2H plus is converting to H2. This is happening in cathode. Like that you have to read out. Which thing converting to which one? H2 is converting to 2H plus by loss of electron, whereas 2H plus is converting to H2 by gain of electrons. Now this is happening in cathode, this is happening in anode. Minus 0.06, how many electron change? 2 electron change. Log of QPC expression what we got? H plus concentration to the power, this is anode, to the power 2 by H plus concentration at cathode to the power 2. Here partial pressure of hydrogen at cathode by partial pressure of hydrogen at anode. Anyhow, this substance will be 1 atmosphere. Already we have to put 1. This will be 1 atmosphere. Now these two if I take common ultimately, and also standard oxidation potential and standard reduction potential for hydrogen assumed to be 0, not 0, it assumed as a 0. So then is assumed as a 0 because with respect to that only other metal, other that substance we used to consider their reduction potential value. That's why the oxidation potential of hydrogen, standard oxidation potential for hydrogen electrode always, or standard reduction potential for hydrogen electrode system is assumed as 0. So then immediately we got here 0, then our expression is coming E cell will be equals to minus 0.06 by 2 log of H plus concentration anode by H plus concentration cathode whole to the power, I am putting the square. Anyhow that part is a 1 by 1 is 1. Now as per this log rule, these two will come over here, then we can write down E cell will be equals to minus 0.06 by 2 into 2 over here log of H plus concentration add anode by H plus concentration add cathode. These two cancel out, then we are getting minus of E cell will be equals to minus 0.06 log of H plus concentration at anode by H plus concentration of cathode. This is one form. From here we can calculate the E cell for hydrogen electrode. Whenever both electrode is a hydrogen electrode, their concentration are different. We can utilize this one. Otherwise, what we can do, we can change in terms of a pH. You look at how we can change in terms of a pH, because we got the expression E cell equals to minus 0.06 log of H plus concentration at anode by H plus concentration at cathode. Then minus log of A by B equals to log A minus log B. So because this is the formula, log A by B will be equals to log A minus log B. So then what I can write down over here itself, before that minus sign is there, I am writing like this way. You look at 0.06, that here I am taking a bracket, minus of log of H plus concentration, this minus I am taking inside, H plus concentration of anode. By default there will be one minus, this minus if I take inside, minus of, and already another minus sign was there, minus of log of H plus concentration of cathode, because that will be nothing but A by B means minus of B, and before that minus sign is there. That's why minus of minus log of H plus concentration, this substance we are getting over here. Now minus of log of H plus concentration, minus of log of H plus concentration equals to what? pH. For the dilute solution, when the concentrations will be less than 1 molar, then we can write down minus log of H plus concentration is nothing but what? pH. This should be clear for dilute solution. Otherwise, I have to take the activity of H plus. So that is the idea. Whenever concentration will be less than 1 molar, then only I can write down minus log of H plus concentration equals to what? pH. Now you look at, instead of that, here we got that expression, E cell will be equals to 0.06 minus log of H plus concentration anode, here minus log of H plus concentration cathode. Then what I can write down, E cell will be equals to 0.06, instead of minus log of this one, I can write down pH of what? Anode minus this one, pH of cathode. That way also we can express that for hydrogen electrode, E cell will be equals to 0.06 pH of anode minus pH of cathode. Now they can give you different way problem. They can give you in that H plus, instead of H plus, they can give you the weak acid, and weak acid you know how to find out the H plus concentration. H plus concentration will be equals to C alpha, alpha equals to under root of Ka by C. That way also we can go and we can explain different model problem based on that hydrogen electrode. I hope you understood this video. If you want to get more this type of video or any doubt you have, you just comment so that I can give you clarity and we can proceed with the confidence. To get this type of more video, please subscribe my channel, like my channel, so that channel can prosper for the betterment of student community. Thank you very much. Thank you all. See you in the next video.